Hello everyone, I am going to explain question number first E and F part from exercise 7.6 from class 12. So we will start from E part. In E part, the function is splitted in two parts. When the x is greater than equal to 0 to less than equal to 1, that time the function is x square plus 1. But when x is greater than 1 but less than equal to 2, that time the function is 3 minus x. So when a function is splitted like this, that time we have to check the function's differentiability, because here both are polynomial function, but here since the constraints are different, that's why we have to check the differentiability. So we are going to check the differentiability of fx in the open interval. It is the second condition of the cross here. Now to check the differentiability, I selected the value of x as 1, because if we have to check for each term which belongs between the open interval 0 to 2. So between 0 to 2, 1 belongs. That's why we have to check whether the function is differentiable at x equal to 1 or not. So to check it, we are going to find out the left hand derivative as well as the right hand derivative, which you might have already studied before in the chapter 6th, that is continuity and limit chapter. So we are going to find out the left hand derivative at x equal to 1. So this is the formula of left derivative. This is the symbol. It's a short form of left hand derivative. So left hand derivative f dash x means we are differentiating. So it's the formula fx minus h minus fx and down minus h, and h tends limit h tends to 0. So in this we have to put the value fx minus h means less than x. So here it's the formula. Now we are going to find out its value. What we are going to assume, x is equal to 1. So replace wherever x is there, replace it by 1. So 1 minus h and f1. So 1 minus h means little bit less than 1. So less than 1. So when x is less than 1, so we will see when x is less than 1, that is this. When x is less than 1 or equal 1, we have to use this function, that is x square minus plus 1. So if x is here, that time x square plus 1. So what we have here, 1 minus x. So instead of x square plus 1, we are going to write down this. Now f1. f1 means when x is equal to 1. When x equal to 1, that time when you will write here 1, that time here also 1, here also 1. So 1 plus 1, what you will obtain? 2. That's why instead of f1, directly I wrote 2. So I hope it's clear to you. First we selected that when function is less than 1. 1 minus h means less than 1. That time what is the value of function? So that will give you x square plus 1. So instead of x square, what we have here? 1 minus h. That's why 1 minus h square plus 1. Now f1. At f1 also the function is x square plus 1. So what is the value of x here? 1. So when we put 1 in x square plus 1, that will give us 2. That's why instead of f1 I wrote here 2. Now we'll simplify it. So for that, first you just open the bracket by using a minus b whole square formula. That will give you this. And you can see this 1 plus 1 is 2 and 2 minus 2 is 0. So we will only remain with h square minus 2h. From here take h common. That will give you here h and here minus 2. Now this h and this h will cancel. So we are remain with only minus sign. So that minus sign will come here. Now apply the limit. When you will apply the limit, it's going to be 0. So minus minus you are going to get plus 2. Now we are going to find out the right derivative of fx at x equal to 1. So when we are going to calculate the right derivative here, that time the symbol is r f dash x, means right derivative of f dash x. So 1 plus h, 1 and plus h. So 1 plus h means more than 1. So at more than 1 we'll see what is the value of function, and when x is more than 1. So when x is more than 1, that time the value of function is 3 minus x. So here when the function is more than 1, 3 minus x. So what is the value of x here? 1 minus h. So 3 minus 1 minus 1 plus h. Now f1 I already described before, f1 is 2. Now simplify it, open the bracket. So when you will simplify, you can see 3 and this minus 3 will cancel. You are remain with minus h upon h, that is minus 1. So right derivative value we obtained as minus 1, but left derivative we obtained as plus 2. Since left derivative and right derivative are not same at particular x equal to 1, that's why function is not differentiable at x is equal to 1, which belongs in the open interval. So second condition of Rolle's theorem is not satisfied, hence the Rolle's theorem is not applicable. So students, in this question directly we switched to the second condition of the Rolle's theorem, because that is not applicable. And as soon as you are going to prove that any one condition is not applicable, you can stop your describing the solution, because it's not applicable, hence Rolle's theorem is not applicable, hence the solution is completed. Now we move to the last part of this first question, that is part F. In F part we have greatest integer function, and you know students that greatest integer function is not continuous, that is discontinuous function. For every number the greatest integer function is always discontinuous. Since the first condition is not satisfying, so no need to move to the any condition, directly write down Rolle's theorem is not applicable. So this you have to learn, that the greatest integer function is not continuous and the modulus function is not differentiable at 0. So some particular conditions are there for particular functions which you must learn to prove the Rolle's theorem. Hence the question number first of exercise 7.6 is completed. And students, if you have any doubt or any suggestions, you can write in the comments so that we can improve ourselves. Thank you.